At first light, the tower does not look like a mountain. It looks used. A dark cylinder rising out of the Wyoming plain, its sides furrowed with long vertical grooves, its top abruptly flattened, as if something immense once stood there and was cut away. From a distance, the scale feels wrong. It is too solitary for a ridge, too deliberate for a hill, too abrupt for a natural slope. The rock climbs in parallel lines, almost like grain. Broken boulders lie at the base in a rough collar, as if the outer skin has been shedding for a very long time. Stand far enough back, and the contradiction sharpens instead of fading. This is supposed to be a landform, and yet the first impression is not geological at all. It is anatomical. It resembles a stump, not metaphorically, physically. The accepted explanation is clear, established, and repeated with confidence. Devil's Tower is described as an igneous intrusion, magma that forced its way upward but never erupted in the ordinary sense, then cooled underground and fractured into columns. Over millions of years, the softer surrounding rock eroded away, leaving the harder core exposed. The vertical grooves are said to be columnar joints, a known result of cooling stress in volcanic rock. In the official timeline, there is no missing giant organism, no lost forest of impossible scale, no erased chapter of Earth history. There is only heat, pressure, uplift, and erosion. The same framework extends outward. Petrified wood is fossil wood. Coal is compressed plant matter. Mesas are erosional remnants. Buttes are what remains after weather and time do the slow work of subtraction. However, the landscape is not a record of vanished giants. It is a record of ordinary geology operating over extraordinary spans of time. And yet there is a reason certain places do not sit comfortably inside their labels. The official explanation can be technically complete and still feel strangely incomplete. It can describe the mechanism and still leave the form unresolved. Because what confronts the eye is not only a columnar rock mass, it is a recurring shape, a vertical body, a broken top, a flared base, debris around the perimeter, radial drainage cutting outward into the surrounding ground. Elsewhere, on other continents, there are flat-topped plateaus, organ-pipe cliffs, isolated monoliths, stone logs, coal seams where forests once stood, and petrified trunks so perfectly preserved that the rings survive in stone. And then there are the old photographs from the age of industrial logging. Men standing on tree stumps large enough to hold a dance floor, a piano, even a small crowd. The problem is not that any one of these facts proves anything by itself. The problem is that together they begin to press against the edges of the official categories. So the hidden theory is not that every strange hill is a tree or that geology is fiction. It is narrower and more serious than that. It is that some of the world's most puzzling landmarks may preserve the remains, or at least the geometry, of a vanished arboreal world far beyond the scale preserved in living memory. That ancient forests were not merely larger, but categorically different. And that in a number of cases, even what is now treated strictly as rock may also be the mineralized residue of once organic structures, reclassified by time, heat, chemistry, and institutional habit. That theory sounds strange because the categories have become rigid. Trees belong to botany, mountains belong to geology, fossils belong to paleontology, extraction belongs to industry. Once the boundaries harden, the pattern disappears. What changed was the explanation. Start with the measurements, because this is where speculation should either weaken or sharpen. Devil's Tower rises more than 1,200 feet above the Belle Fourche River, and its summit spans only a few acres. The sides are dominated by polygonal columns, many remarkably straight, descending in long vertical bands. The top is comparatively level. At the base lies a tailless field of fallen columns, all broken into sections that resemble shattered lengths of some once coherent outer shell. On paper, all of this is consistent with an intrusive igneous mass. But the morphology remains unsettling. The columns do not merely descend, they read like fibers. The outer profile is not simply steep, it is abrupt, almost cylindrical. The summit does not taper like a peak, it terminates. And around many isolated buttes and towers, the surrounding landscape is cut by drainages that spread outward in a rough radial pattern, like channels formed around a central anchor point. None of this proves an arboreal origin, but it does something more important than proof. It establishes that the resemblance is structural, not poetic. The shape is not an accident of language, it is in the stone. Then the historical record widens the scale of what a tree can be. Out in the 19th and early 20th centuries, photographers repeatedly documented stumps so large they were turned into platforms, intersections, tourist attractions, and temporary buildings. Northern California redwood stumps held dance parties, roads were cut through living trunks, logging camps used stump tops as stages because they were broad enough to use that way. Historical accounts describe coast redwoods exceeding 350 feet, and there are documented cases approaching 380 feet. In Australia, reports of mountain ash, Eucalyptus regnans, reached beyond 400 feet in the 19th century, even if some of those claims remain debated. Old Douglas fir reports did the same. The numbers matter, but the photographs matter more. They remove abstraction. They show that within the very recent human past, other trees existed on a scale large enough to distort architecture, labour, transport, and memory. Once that is admitted, the psychological barrier weakens. If known forests could produce trunks large enough to host a crowd, then the leap from ordinary tree to extraordinary tree is no longer absurd. It is a question of degree, not kind. The record is still there. Now move to fossilization, because this is where the boundary between wood and stone becomes less stable than it seems. In Arizona, entire logs lie transformed into quartz-rich stone, their original cellular structure preserved in mineral replacement. In Yellowstone, successive forest horizons were buried, altered, and exposed, leaving upright stumps and layers of ancient woodland entombed by volcanic materials. In Patagonia, on Lesvos, in Egypt, out in scattered basins across North America, there are petrified forests where wood has ceased to be wood while remaining recognizably tree. Rings remain, bark textures remain, internal grain remains. Chemistry changes first, form lingers. This matters because the official categories encourage a false separation. We are taught to imagine a tree as organic and a mesa as geological, as if the two belong to incompatible worlds, but the fossil record says otherwise. Organic structures can become mineral structures, forests can become rock, entire landscapes can preserve life in lithified form. Once that is understood, the question changes. It is no longer, can wood become stone? It plainly can. The question is, how much of a former living world can survive after mineralization, compression, heat, burial, and an erosion reshape it almost beyond recognition? The stone remembers. There is also the matter of coal, lignite, and buried forest horizons, which sit uncomfortably in the middle of this discussion because they are treated as fuel deposits rather than as historical evidence. Coal is the industrial afterlife of ancient plant worlds. Mines across Europe, North America, Russia, China, and Australia cut through seams that represent compressed vegetation on a scale modern forests do not approach. In some coal-bearing strata, bright fossil trees have been found penetrating multiple layers, preserving the position of growth rather than simple transport. In other places, miners documented root horizons, carbonized trunks, and stacked vegetal beds. The official explanation again is not absurd. Ancient swamp forests accumulated, were buried, out-compacted, and altered over deep time. But what matters is the implied scale. Entire economies were built by burning the remains of forests so large they became seams hundreds of miles wide. Industrial civilization did not merely use wood from trees it could see. It was powered by forests it never saw. That should change how we read the landscape. A vanished arboreal world is not fringe in principle. It is foundational to modern history. We have been burning its remains for 2 centuries. A fair reading of the mainstream view is necessary here because the strongest anomalies are not protected by denying real geology. Columnar jointing is real. It can be observed in lava flows and intrusive bodies around the world. Basalt cools, contracts, and fractures into polygons. Devil's Postpile, Giant's Causeway, Fingal's Cave, and many volcanic formations show versions of the same process. Laboratory analogues and field studies support it. If a rock mass cools under the right conditions, columns form. That is not a weakness in the official explanation. It is one of its strongest points. But strength in one area does not settle every case or every implication. It explains the columns. It does not fully explain why certain formations also present the macroscopic logic of biological forms: terminated tops, stump-like proportions, bark-like outer segmentation, debris collars, and surrounding geomorphology that suggests something once centered there. Nor does it explain why public interpretation so often gravitates toward organic comparison before anyone teaches it to. Mainstream geology tells us how the fracture pattern forms. What it does not always answer is why the larger silhouette feels so uncannily familiar. The industrial archive adds another layer, and this one is less romantic than people expect. When enormous trees stood in the path of expansion, the response was not awe, it was engineering. There are patents for stump pullers, stump burners, blasting methods, cable systems, and steam-powered extraction equipment designed specifically to remove root masses too large for ordinary labour. Railroad spurs were laid into forests solely to move timber. Logging companies built temporary towns, inclines, splash dams, and donkey engine systems to drag trunks that no animal team could manage. Court records, land surveys, insurance valuations, and timber deeds all reduced living giants to board feet and claim boundaries. This matters because the disappearance of colossal forests did not require a dramatic secret. It required markets, fuel, steel, rail, and time. Once the resource could be measured, it could be liquidated. Once it could be liquidated, it could be normalized. A landscape can vanish without becoming mysterious in the moment. Only later, when the scale is gone and the paperwork is scattered, does the loss begin to look impossible. And when the scale widens beyond a single tower, the pattern repeats in ways that are difficult to ignore. There are isolated monoliths standing apart from surrounding terrain like residual cores. There are flat-topped buttes with sharply defined sides. There are petrified forests in multiple climates. There are stone logs large enough to challenge ordinary proportions. There are coal basins that testify to botanical abundance beyond modern analogues. There are landscapes stripped of old growth so completely that later generations inherited only names, stump fields, and second growth stands, and assumed the previous world had never been very different. There are places where local traditions describe giant trees long before modern fringe theories noticed them. There are maps and survey notes that refer to timber, buried wood, silicified trunks, or forests, where little remains now. The important point is not that one explanation must fit every case. It is that the cases may not be as separate as they appear. A petrified forest, a coal seam, a stump field, and an isolated tower are usually studied by different specialists under different institutions, with different funding streams and different vocabularies. The landscape is continuous, the archives are not. This is where the quieter explanation for concealment becomes more plausible than the dramatic one. Not conspiracy, classification, not a single deliberate lie, but a series of professional partitions that make certain questions difficult to ask. Geologists describe lithology, fracture mechanics, and stratigraphy. Paleobotanists study fossil wood, foresters study living stands and harvested yield, mining historians study extraction, archivists catalogue photographs by place and date, not by the pattern hidden across collections. Bureaucracy does not need to suppress a theory if it can dissolve it into departments. Economics does the rest. Timber becomes lumber, coal becomes energy. Our petrified wood becomes a curiosity or a park exhibit. A monolith becomes a scenic landmark. Once each fragment is assigned to a harmless category, the larger continuity no longer presents itself. The truth, if there is one here, may have been hidden the way many important things are hidden, in plain sight, beneath labels that are technically accurate and intellectually narrowing. The pattern does not disappear, it is filed. There is another clue in what remains missing. If the world once carried forests of a scale modern people would find almost implausible, where is the transitional evidence in ordinary memory? Why do the surviving examples feel so fragmented? Part of the answer may be that giant things do not leave simple ruins. They leave industrial systems, disturbed ground, odd place names, salvage economies, fires, quarries, out rail grades, mill foundations, and enormous quantities of secondary material folded into cities, mines, ships, telegraph lines, paper, fuel, chemicals, and export ledgers. They also leave absence. Walk many of the world's famous landscapes, and the dominant feeling is not merely grandeur, it is aftermath. The old growth is gone, the topsoil is thinner, the rivers are channelized, the stump fields have rotted down. The records of extraction are boring enough to be ignored. A museum display can preserve a cross-section of a giant trunk while obscuring the industrial violence that made such displays possible. Memory contracts to fit the present terrain. We assume the world was always approximately what it is now, only a little wilder. The archive suggests otherwise. Even language gives the game away. We still speak of forest giants. Dow's cathedral groves, buried forests, petrified forests, fossil wood, root wads, stump ranches, old-growth remnants, and timber kingdoms. The vocabulary preserves a scale the landscape no longer carries openly. In many places, indigenous names and early settler descriptions emphasize singular trees, sacred groves, unusual pillars, or standing forms that did not behave like ordinary hills. Later scientific language regularized those features, often for good reason, but also at a cost. Something was gained in precision and lost in perception. To call a thing an intrusion may clarify its mineral origin. It may also discourage the eye from noticing what the shape still insists on showing. This is not an argument for abandoning science. It is an argument for looking harder at form, timing, and continuity. When wood becomes stone, when forests become fuel, when extraction becomes scenery, explanation can become a veil. The official explanation is often true in part. The contradiction is that part of the truth may not be the part we were taught to see. So what remains? Not certainty, not a finished alternative history. What remains is a chain of evidence that is individually ordinary and collectively destabilizing. Landmarks that resemble severed trunks more than mountains, fossil wood on continental scales, coal as the compressed residue of vanished plant worlds, industrial photographs proving that recent trees already exceeded our intuitive sense of scale, and institutional boundaries that keep related evidence from being read together. None of this compels a single conclusion, but it does justify a different posture. Less ridicule, more inspection. It's less confidence in inherited categories, more attention to what physical forms are actually saying. A tower can be volcanic and still belong to a larger pattern of lost arboreal worlds. A petrified forest can be a textbook fossil site, and also a warning that the line between landscape and organism is thinner than modern thinking allows. The strangest ideas are not always false. Sometimes they are what remain after ordinary explanations have answered the mechanism, but not the shape. Look again at the tower on the plain. Look at the broken columns at its base, the abrupt top, the fluted sides, the way it stands alone as if isolation itself were part of the evidence. Look at the photographs of men dancing on redwood stumps, the mineral grain in petrified trunks, the coal seams laid down by forests no human ever saw, the survey notes, the patents, the ledgers, the vanished old growth, the debris fields, the names that linger after the thing itself is gone. The world may not be hiding a fantasy, it may be hiding scale. And scale, once lost, becomes almost impossible to imagine accurately. That is why the theory feels strange. Not because it has no evidence, but because the evidence is scattered across stone, timber, fuel, maps, and bureaucratic drawers that were never meant to be read as one story. The real question is not whether the theory sounds strange, but whether anyone with the tools to verify it has seriously looked.